For this next direct variation example, we're given a slightly different description of the problem and the relationship between the two variables. So the two variables that we have and are studying in this example are the weight and the height of this supposedly identical body type. We are told that the relationship between them will vary directly, so we're going to start with our direct variation equation, y is equal to kx. But this one's a little bit different. We have this added extra piece that the direct variation is not necessarily with x, but instead with the cube of x, or the cube of the height, the independent variable. That doesn't change our solving process at all, except for the fact that we're going to add in an extra cube on our independent variable. So the relationship is not between weight and height, it's between weight and the cube of the height, which is not necessarily the same value. Actually, it's not the same value, unless the x is 1. We're asked about the world's tallest man being 107 inches, and then what was his weight at the time of his death. But we're not going to start there. We're going to start with the relationship that we know. And that relationship is that a man who is 70 inches tall with that same body type would weigh 170 pounds. Those are the numbers that we sub into our direct variation equation in our attempt to figure out what k is. We work with the part of the relationship that we know. 170 is equal to k times 343,000. Divide both sides by 343,000, and we get that k is approximately 0.000496. A very small value. A very small value. Usually this kind of value would be written in scientific notation, but for our purposes, we're going to be doing some operations with it, so it makes sense to round it a little bit so we can see it in the equation. We sub that into our direct variation equation, into the spot where k would normally be, and we finish with our cube again. Don't forget the cube when you rewrite after knowing what k is. We're now going to determine the weight of the tallest man, 0.000496 times 107 to the third power. Notice that the y variable is already solved for us, so it's just a matter of doing this calculation over here. And if done correctly, you should get that the man's weight is approximately 607 pounds. Now, depending on how you rounded this value, will determine how accurate of an answer you get. This was a non-terminating, non-repeating decimal. This decimal was going on, I shouldn't say non-terminating, non-repeating. This decimal was going on forever. Okay, this decimal was going to extend beyond the ends of the 6 decimal places that we wrote. Because of the size of this number, 107 to the third power, it will be sensitive to how we rounded that, because 107 to the third power will get out to place values where the numbers that would be after that 6 would matter. So while that's a decimal, and excuse me again that I misspoke before, because this decimal goes on forever, we're not in a position to write all of those decimal values, so we make a choice to round somewhere. Depending on where you chose to round, you might have written 0.0005. That will affect this answer because of the size of the 107 cubed. So you want to be careful if you take an approach to answering a question like this and your answer doesn't match exactly to the solution provided or to someone else's answer. It's all a matter of how you approached that k value, how many of the decimal places you were able to hold, and truthfully what makes sense to hold, because you shouldn't just be writing out all of those place values. But again, that occurred because of the role that that massive 107 to the third played when it was multiplied by that value of k.